everyone, so today's topic is higher tier only, and today we'll be calculating the areas of sectors and segments of circles, as well as finding the radii and sector angles in the context of real life problems. So first of all, let's make sure that we are confident with labelling parts of a circle. So if we have a circle, remember the perimeter of a circle is called the circumference. The line that cuts the circle in half going through the centre is called the diameter. Remember that half the diameter is called the radius. This line here is called the chord. And then this section here, between the chord and the circumference, this is called a segment. And the smaller shaded part would be called the minor segment, and then the larger one would be the major segment. If you have part of the circumference, so for example with me highlighting here, that part is called an arc. And then if you have, for example, a slice of pizza, that's what it looks like anyway, that is called a sector. And we'll be finding the area of these sectors in today's lesson. Okay, so let's look at this word sector in a bit more detail. A sector is the area between two radii of the circle. The minor sector is the smaller of the two sectors shown in yellow, and the major sector is the larger of the two sectors. But don't worry too much about the words of the minor and the major sector. Just think about that a sector of a circle is like a slice of pizza. Let's look at this question here. So it says that this circle has a radius of 4 centimeters. So you can see that from the center to the circumference, that's the radius, that is 4 centimeters. Something that's also important to remember, that if that length there is 4 centimeters, the length of this radius here is also 4 centimeters. And the sector has an angle of 60 degrees, as you can see it's labelled there. The question that we are going to be looking at is find the area of the minor sector. So we need to find the area of this pink shaded area. We know that a sector is a fraction of the whole circle. So for example, if you had a semicircle, that would be half the circle. So here we have a fraction of the circle with this sector. But what fraction is it? Well, the way that we work this out is that we know that the angle around a point is 360. So the angle all the way around here is 360 degrees. This section here is 60 degrees. So the fraction of the circle that this sector is going to be 60 out of the 360 degrees in the entire circle, which we can write as a fraction, 60 over 360. We can use this fact to help us with finding the area of the sector. Now let's think about if you find the area of the whole circle. The area of a circle, hopefully you all remember the song, is pi r squared. Okay. However, we only want to find the area of the sector. Now, if, say for example now, we had this circle and the sector was exactly a quarter of the circle, how could we find the area of that? Well, you could find the area of the whole circle and then just find a quarter of it. It's the same thing here. To find the area of the sector, what we will do is we need to remember what the area of a circle is, and it's the fraction of that circle multiplied by it will give us the area of a sector. So let's look at that in a general way then. Area of a sector is going to be the angle of the sector over 360 degrees multiplied by the area of the circle. And how we write that down is the angle is given this letter here. This letter is called theta. Okay, so in the way that we draw theta is we draw like an O or a 0 and then put a little line through it. Okay, so it's theta over 360 multiplied by pi r squared, and that is the formula that we need to remember. Okay. Now, this will make a bit more sense when we try this out with an example, as it always does in lessons. So let's look at, find the area of the shaded sector. So the pink section here. First of all, as always, we start off by writing down the formula. So we're finding the area of a sector, which is theta over 360 times pi r squared. This is not given to you at the start of your exam, so you will need to remember it. The theta is the angle, so that's going to be 72 over 360 times pi times the radius, which is 10 squared. So if you type that into your calculator, that will give you 20 pi. Pressing S to D, then that will be 62.831853, which then, if we round that to 2 decimal places, is going to be 62.83 centimeters squared to 2 dp. And that's it. Okay, let's try out another example then. Here again, the question is asking us to find the area of the sector. We always start off by writing down the formula. So theta over 360 times pi r squared, which is going to be 50 over 360, because the angle is 50, the angle around a circle is 360, multiplied by pi times the radius, which is 18 millimeters squared. Again, type that into your calculator. Your calculator will show 45 pi, which then in pressing ST will give you 141 that's meant to be 141.37166694, which rounding it to 2 decimal places is going to be 141.37 millimeters squared. Remember, be careful of the units, to 2 dp. Okay, let's step it up a section then. Here it says you're given a segment of a circle, find the area of the segment. So they want us to find this shaded orange segment here. How will we do that? Well, first we're going to work out the area of the sector. That's this whole sector here, by using the formula that we've just learnt. And then we're going to take away the area of the triangle, okay, using the formula that we learnt for finding the area of a triangle, using the formula half AB sine C. Let's try that out then. So first of all, let's find the area of the sector. First of all, write down the formula, subbing in the values that we've got. So the angle is 80, the radius is 5 squared, it's 5, sorry. So that will give you on your calculator 50 over 9 pi, which will then give you 17.453292. Now, because we're going to be using that length, that area for the next part, keep it to as many decimal places as you can for accuracy. Now let's find the area of the triangle. Now you may find it easier to also draw out the triangle. Okay, so this is 80, so that's going to be the angle C. The radius is on either side, so if we call this little c, then this one can be capital B, this will be small b, this will be little a, and that'll be capital A. Okay, subbing in the values that we've got then, so we've got a half times a, which is 5, times b, which is 5, times sine 80. Now make sure that your calculators are in degrees, please. So type that into your calculator, you'll get 12.31009691. So that's most of the hard part done. So the area of the segment, that's all you now need to do is to subtract the area of the triangle from the area of the sector, which will give you 5.1431, which will be 5.14 centimeters squared to 2 dp. You could also be asked to work backwards and work out what the radius is, or to work out what the angle is. So here, a sector has angle 35 degrees and an area of 200 centimeters squared. What is the radius? Again, we know that they're testing us on working out the area of a sector. So first of all, let's write down that formula up here. So area of sector equals theta over 360 times pi r squared. And now let's substitute in what we have been given. So we've been given that the area of the sector is 200. We've been given that the theta, the angle, is 35. And then pi is as it is, but we need to find the radius. Okay. So with this then, you may want to type in to see if that 35 over 360 will simplify at all. It doesn't simplify, it simplifies down to 7 over 72, which doesn't quite help you. So here what we need to do now is get r squared on its own. What you may want is to write down, to get that r squared on your left hand side, you don't have to do this. Okay, but then here you can see the first thing we may want to do is to get rid of this section here where we're multiplying by 35 over 360 by dividing by that. Typing that into your calculator, you will get 2057.14285. So then, to have r squared on its own, we will divide that by pi. So that will give us r squared to equal 654.808987. Okay, if I go up here then, as I'm running out of space, and so to get r, then we need to square root that. Giving us an answer of 25.58923. So to 2 decimal places, that will be 25.59 centimeters.